Thank you for your invitation. So, I'm from Catania, Center of Excellence for Acceleration of Harm Reduction, and our study today that I present today start from this working hypothesis, because the effect of a cigarette on pathogenic bacteria is little studied, and the reported results are conflicting because there are any clinical studies that report improving in pathologies such as asthma, COPD, or rhinitis, probably due to a reduced incidence of bacterial infection. Conversely, some in vitro studies suggest an increasing of predisposition to infection. But we know for many years, I found the first report in 1942 that, I use my laser, that a common ingredient of a liquid that is propylene glycol have antibacterial activities. And we know that other vegetal glycerol have bacteriostatic activities. So the aim of our study was to determine the effect of e-liquids on bacterial growth. We selected a popular brand that is composed by 50/50 PGVG and with 18 milligram per microliters of nicotine, and asked to the manufacturer to furnish us the nicotine and flavors-free formulation in order to assess the antibacterial activity by standard microbiological test. The flavor components, the major flavor components of these liquids was menthol, vanillin, transanethol, and eucalyptol. Okay, so we tested 4 formulations. A formulation with PGVG and flavors, a formulation with only PGVG, a formulation with PGVG, flavors, and nicotine, and a formulation with only PGVG and nicotine. The antibacterial activity was assessed against these strains: Escherichia coli, Enterococcus fecalis, Yersinia lutea, Staphylococcus aureus, Pseudomonas aeruginosa, Klebsiella pneumoniae, and Acinetobacter baumannii. We used as quality control the ampicillin, that is a broad-spectrum antibiotic, and as negative internal control, as named normally as blank, we used PBS and glycerol 50/50% volume per volume. The 3 tests that we performed was the agar-well diffusion test in order to investigate the antimicrobial activity of our liquids, the susceptibility testing in order to determine the MIC, that is the minimum inhibitory concentration for the activity of liquids on bacteria, and we draw the growth inhibition curve analysis in order to determine the effect of different liquid dilution on bacterial growth along the time in 24 hours. Briefly, I want to show the principle, because I think that there aren't microbiologists. So the agar-well diffusion assay is performed by placing four stainless steel in a sterile plates, and and therefore we add the broth warmed, the agar warmed with bacterial strain, and after the solidification of this broth, the stainless steel were removed, and they left a hole that we call well. So the name agar-well diffusion test. We put 100 microliter of in total liquids in these wells, and observed if these liquids can diffuse in the gel and if they suppress the growth of bacteria. In fact, okay, you can see here this halo. This halo is the suppression of growth of bacteria. The bacteria are present in all the plate. We put the no flavors liquid in these two wells. The flavored liquids in these two wells. Here we put the nicotine-free, the liquids with nicotine and nicotine-free liquids. Okay. So here we can observe the zone of growth inhibition measured in millimeters by a gauge, and so the diameter, you can see that without flavors, only on Pseudomonas aeruginosa and Klebsiella pneumonia, this is the liquid without flavors, but with nicotine, this is the only PGVG liquids, and this is the liquid with flavors that have a good effect on all the bacterial strain tested, and with nicotine the effect is little increased. This is the principle of susceptibility testing in order to define the MIC, the minimum inhibitory concentration, and this is performed by the guidelines for microbiology. We prepared a serial dilution of the liquids, 1 to 2, 1, 4, 1, 8, 1, so. And after that, we put the bacteria in this broth, that is a liquid medium, and the concentration at what the bacteria don't grow was defined as MIC. This is the minimum concentration effective to block the growth of bacteria. This is an example of the multi-well plate that we used to give this determination. And this is the result. Here we show the different concentration needed to stop the growth of bacterial strains for each liquid. Therefore, this is the concentration of liquids in a percentage volume to volume, and the lower values, difficult. The lower values correspond to an high activity. So, without flavors, we had this activity, okay? But with flavors, as you can know, the liquids was more active, and with flavors and nicotine, almost more active. This is an example of the growth inhibition curve. If the MIC is determined after 24 hours of incubation, the growth inhibition curve is the same experiments, but conducted by a dynamic microplate reader. So we can observe the effect along the time for 24 hours. This is the effect of the only PGVG liquids that have a good effect at a concentration of 12.5% volume to volume. And you can see that at 6.25, there is a certain growth. Adding nicotine to this, the effect increase, and with flavors, it's similar to that of nicotine, but with nicotine flavors, the effect is almost complete of inhibition at 6.25 of concentration, percent of concentration. So in conclusion, we observed that a liquid under investigation show bacteriostatic and bactericidal activities on several strains. That bacteriostatic and bactericidal activity of liquids can be referred to partly to all the components of liquids, PGVG, flavors, and nicotine. And nicotine and flavors seem to have an additive effect. Obviously, this is a study only to test the activity of e-liquids, or the bus activity. We obviously have to continue with the test of in vitro experiments using the aerosol from e-liquids in order to give a conclusion on the use of e-cigarettes on humans. Thank you for attention.